Okay, let's dive into a truly mind-bending idea.
Hmm.
For a long time, quantum mechanics, especially when we talk about fundamental particles, has seemed, well, intrinsically tied to something called imaginary numbers.
That's right. The complex plane seems essential.
Today, though, we're exploring a radical proposal that challenges that very foundation.
A real valued Dirac equation.
Exactly. The Dirac equation is, a cornerstone of relativistic quantum mechanics, famously merging it with special relativity, even predicting antimatter.
Yeah,
Huge stuff.
absolutely.
But it always relied on this I, the
Mhm.
imaginary unit. So our mission today is to explore a new formulation derived from unified quantum mechanics, UQM they call it, which proposes replacing that imaginary I
Replacing it.
with a real valued operator, the Hilbert transform.
That's fascinating because the standard Dirac equation, it's just so fundamental for describing spin 12 particles like electrons, and it's inherently complex valued. You see that I in the very building blocks, like the operators for energy and momentum. Right, and that complex nature is usually tied to the probabilistic interpretation, right? How we get probabilities out.
Yeah, makes it statistical.
Yeah.
And the standard view assumes local interactions. What happens now only depends on the immediate past, basically.
Exactly, like a series of snapshots, one influencing the next. But takes a fundamentally different path, suggests maybe a deeper interconnectedness.
Now, this is where it truly takes a captivating turn. UQM suggests replacing that ubiquitous I with something called the Hilbert transform operator. Why? I mean,
Yeah.
why swap out what seems like a basic mathematical need? What is this Hilbert transform?
Well, what's fascinating here is that the Hilbert transform, or math Kalechi, it isn't just a point-in-time thing. It's a non-local integral operator.
Non-local. So not just about right now.
Precisely. Imagine it like a mathematical process that looks at the entire history of a system to figure out its state now.
Its whole history.
Its entire temporal evolution, which is a fundamental departure from that local snapshot view of standard quantum theory.
Yeah.
It basically shifts the phase of a function's frequencies without making the function complex itself.
Wow. Okay. That's a profound shift.
Okay.
So if the present isn't just isolated, but tangled up with the past and future, what does that do to causality? And this new real valued equation, this modified Dirac equation, what does it actually show us?
Well, it raises this really important question. Can quantum mechanics even work without complex numbers?
Right.
And this framework, it rigorously demonstrates that the real and imaginary parts of these standard complex solutions to the Dirac equation,
Yeah?
they are themselves exact solutions to this modified real operator equation.
Wait, so the old solutions still work, just
Wait,
differently.
Kind of. It shows mathematical consistency. It's not just a trick. It's a rigorous demonstration that maybe the whole structure of quantum mechanics doesn't inherently need imaginary numbers.
That's quite something.
Yeah.
So what we thought was fundamental might just be, like, emergent.
That's the implication. And connecting this to the bigger picture, introducing the Hilbert transform means the present gets entangled with past and future, a more intricate, non-local causality.
Which could link up to other areas, maybe, like quantum gravity.
Potentially. It offers a novel perspective, maybe bridging gaps through ideas like causal sets or holographic principles, suggesting a deeper, interconnected structure to reality. And there's more. This real valued approach, it supports an ontological view of the wave function.
Ontological,
Yeah.
meaning it's physically real, not just math.
Exactly, like a genuine physical field in space-time, like, say, an electromagnetic field, rather than just an epistemic tool, something that just represents our knowledge.
That challenges the whole Copenhagen interpretation, doesn't it?
It certainly pushes against the view that quantum waves are merely abstract probabilities. Plus, the framework shows particles and antiparticles emerging symmetrically from one single real field, a unification.
Okay, that's incredible. Real wave functions and no need for complex numbers. This must be shaking things up a bit.
It's definitely a paradigm shift. And maybe one of the most exciting bits is the potential for observability.
Observing what? The wave function itself.
Well, the formulation suggests that phase information usually hidden in standard quantum mechanics might be directly extractable, like using the Hilbert transform on the measured way.
So you could actually, potentially, see these quantum waves experimentally, reconstruct them.
That's the hope. It opens pathways we didn't think were there.
Just think about that for a second. If quantum waves are physically real and we could potentially observe them, that changes everything. How we interact, how we understand quantum stuff. It sounds a lot like some other interpretations, like de Broglie-Bohm theory. that also treat the wave function as a real thing, a guiding wave.
There are definite parallels in the realist perspective, yes. Suggests we might one day image these waves. Ultimately, this whole framework suggests that what we perceive as complex quantum mechanics, needing that eye, could actually emerge from more fundamental real operators. It reconciles quantum theory and relativity through this deep temporal interconnectedness.
So what does this all mean for you, listening right now? It means the fundamental nature of reality, the very fabric of space-time. It might be far more interconnected and maybe more real than we ever imagined. What if the universe isn't just locally connected moment to moment, but globally correlated across all of time? Past, future, influencing the present in subtle ways.
A universe that remembers its entire history.
Exactly. This deep dive really challenges us to rethink the very nature of quantum reality. Something to definitely mull over.